So in the previous example, we determined the potential at the center of a metal sphere which was surrounded by the dielectric. And when we did this, we first determined the electric displacement. From that, we got the electric field, and then we could go on to determine the potential. So there was no need to calculate the polarization first. However, we can calculate the polarization in a fairly straightforward manner. So what we would have is our polarization would be equal to epsilon naught times the electric susceptibility times the electric field. And when we substitute for the electric field, what we're going to have is epsilon naught by chi by the charge divided by 4 pi epsilon all squared in the r hat direction. So from this we could then go on to determine what the volume charge density and what the surface charge density is. So for volume charge density, we have rho, and this should be equal to minus the divergence of the polarization. And when we take the divergence, what we're going to get is 0. Now for the surface charge density, what we have is our sigma equal to P dot n hat. And we're going to do this for both the outer surface, which is located at B, and the inner surface, which is located at A. And what we would obtain then is epsilon naught by chi E by Q divided by 4 pi epsilon by B squared. Okay, so this is for the outer surface. And for the inner surface, what we're going to have is minus epsilon naught chi E Q divided by 4 pi epsilon A squared. And this is for the inner surface. Okay, so now the negative sign comes from the fact that the n hat pointing outwards, okay, with respect to the dielectric. So what this means is that at B it's going to be a plus r hat, while at A it's going to be a minus r hat. Okay, so this layer of negative charge is going to reduce the field within the dielectric.